Hello dear students, welcome again. Today we are going to start the new chapter Matrices. Matrices is actually the plural form of matrix. In this chapter we are going to learn the basics of this concept. What is a matrix, different types of matrices, the basic operations that we do on matrices like addition of matrix, subtraction of matrices, multiplying a real number to a matrix or multiplying two matrices, etc. Finally, at the end of the chapter, we are going to learn about what is invertibility of a matrix and one of the procedure to find inverse of a matrix, that is by using elementary transformations. So this is all we are going to learn in this chapter. Obviously, when we start a new topic or new concept, a curiosity will be there in every student. The major question is where this concept is going to use. If that is the case, luckily one of the application has been introduced in our class 12 syllabus, that is to solve system of linear equations we are using the concept of matrix. That you are going to learn in the next topic. If you want to know more details, more applications about this matrices, I had given a link in the description. You please watch that video. It is about 20 to 25 minutes where it describes the real-time application of this matrix. Definitely you are going to enjoy that video. Now let us start the basics of this matrices chapter. As I said, matrices is the plural form of matrix. Now let us see what is meant by a matrix is. Matrix is defined as is an ordered rectangular array of numbers or functions. Now let me write the set of numbers, array of numbers. So I am writing 1 by 2 minus 3, say 7 root 5 3 by 2. Now I write say 3 plus I, 2i, say root 3i, minus 5, 7 plus I, 1 minus I, minus root 2i, 8i. Now let me write some more. Say I write x square plus 1, x minus 2, sin x, e power of x. So these are the numbers. Numbers may be either real or complex. Array of numbers, either real or complex, or maybe functions. Here I written set of functions. How I written? Not randomly. Systematically they are arranged in the form of rows and columns. What is row and column? A row is nothing but horizontal lines of elements will constitute a row of a matrix. And column is nothing but vertical lines of elements will constitute or is going to form the column of the matrix. Now observe here. The horizontal lines of elements, that is 1 by 2 minus 3 are written along this row. So this is row number 1. 7 root 5 3 by 2 are written along another row. So this is row number 2. Now observe the elements vertically. That is 1 7 written along a column. So this is column number 1. 1 by 2 root 5 present in second column. Another vertical line of elements, that is minus 3 3 by 2. So this is third column. So like this we arrange the numbers in the form of rows and columns. Then we need to enclose these numbers using either square brackets or round brackets or pair of vertical parallel lines. Either of these three notation. Throughout the chapter, we have to maintain any one. If you are using square bracket, throughout the chapter use square bracket. If you are using round bracket, you have to use completely this round bracket. You stick on to any one notation. Here, let me enclose these numbers in square bracket. The numbers which form matrix, here 1, 1 by 2, minus 3, etc. They are called elements of the matrix or members of the matrix or entries of the matrix. These entries are elements of matrix usually denoted by small alphabets, maybe A, B, C, etc. They represent the elements of the matrix. And the whole matrix is denoted by capital letters. As an example here, I denote this by A. So this is a matrix which is denoted by the alphabet A. So A is a matrix in which it contains 2 rows and 3 columns. Now here complex numbers are there. Again let me enclose them using square bracket. Say give some name, maybe B. Here it contains arrangement of functions. So let me write it as matrix C. So A, B, C are clearly matrices because the definition says arrangement of numbers or functions in the form of rows and columns. So these are all the perfect examples of matrices. Now let me check what is order of the matrix. Order of the matrix gives us the information about how many number of rows are there, how many number of columns are there in that matrix. Definition goes like this. A matrix having m number of rows and n number of columns is said to be of order m by n. Now here this matrix contains 2 rows, 3 columns. So we have to say that order of this matrix is 2 by 3. While writing, it should be written as 2 cross 3, and while reading, it should be read as 2 by 3. Okay, now come to this matrix. What is the order of this matrix? Simply count number of rows and columns. How many rows are there? 1, 2, 3, 4. 4 rows are there. How many columns? Column number 1, 2. So therefore, order of this matrix is 4 by 2. Remember, while writing the order, we need to maintain a specific pattern. The first number always represent row. The second number represent number of columns. So this particular number is representing how many number of rows are there. The second number is going to represent number of columns. So this pattern we need to maintain. It's not like that 4 by 2 is same as 2 by 4. Definitely not. 4 by 2 refers to there are 4 rows and 2 columns. If you write 2 by 4, the matrix will be containing only 2 rows, 4 number of columns. So this pattern you have to remember. Always row and then column. What about order of this matrix? Count how many number of rows and columns are there. It is very clear, it contains only 2 rows and 2 columns. Therefore, order of the matrix is 2 cross 2 or 2 by 2. I hope it is clear. And now let me tell about the elements. Each element can be identified uniquely with its position. How can I identify the position of the element in the matrix? Now suppose I took this 3 by 2. I want to know what is the position of this element 3 by 2. It is very clear. This element is present in which row? Second row. In which column it is present? Second column. It is second column, second row, third column. This 3 by 2 is present in second row, third column. So therefore, it is denoted by this symbol. Small alphabet, as it represent element of the matrix. In suffix I written 2 numbers. What those 2 numbers represents? Again, that element present in second row and third column. The first suffix indicates the row position of that element. Second suffix indicates column position of that element. So here A23 stands for an element of the matrix which is present in second row, third column. In this case, it is nothing but 3 by 2. So therefore, in this case, it is A23 equal to 3 by 2. Now let me tell what is the position of this element. Check again, that element is present in which row, which column? It is present in first row and second column. How to denote it? First suffix is 1 because it is present in first row. It is present in second column. So write the second suffix as 2. So what is its value? It is 1 by 2. An element of the matrix present in first row, second column, and its value is equal to 1 by 2. Now, can I tell what is the position of this element? In which row it is present? First row, second row, third row. So it is present in third row. In which column it is present? In first column. So therefore I can write its position is B31 I written just for convenience. I can use A. Since I name the matrix as B, I written small alphabet B, indicating it is element of the matrix B present in third row, first column. So B31 value is how much? 7 plus I. Similarly, what is the position of this element? Yes, in which row it is present? Fourth row. In which column it is present? Second column. So therefore, I write it as B42. This is how we denote. This is about position of the element. Now let me write completely this matrix in terms of their position. I am not going to write the elements. I am replace each element by these symbols. So what the first element I had to write? A11. Indicating it is element of the matrix present in first row, first column. What is its value? With respect to this matrix, its value is equal to 1. Similarly, A12 I had to write next because this is an element of the matrix present in first row and second column. This is first row, this is second column. Nothing but 1 by 2 is its value. What about position of this element? First row, third column. You observe here, we written all the first suffix as 1 because they are all elements of first row. When you are writing the elements of first row, remember all those elements will have their first suffix as 1. You are writing the second row elements means their first suffix all equal to 2. If you are writing third row elements, all their first suffixes will be equal to 3. Okay. Now, second row elements I am writing. First suffix is 2 and second suffix, since it is present in first column, it is A21. Second element present in second row, second column, therefore it is A22. This is A23. Now observe the elements column wise. If you observe the elements column wise, here I am specifically taking the second column elements. Look at the second suffix, there too. Now observe these third column elements. Look at the second suffix, there 3. Look at the first column elements. Observe the second suffix, they are all 1. When you are writing the column wise, elements column wise, the second suffix will remain constant. When you are writing the first column elements, their second suffix will be 1. When you are writing the second column elements, the second suffix will remain 2. When you are writing the third column elements, the second suffix remains constant, that is 3. Now with this idea, let me write a general matrix of order m by n in terms of the position of the elements. Here I written m by n matrix. M by n matrix means it has m number of rows and n number of columns. Let me write the first row elements. A with suffix 1 1, element of the matrix present in first row, first column. A12, A13, etc. At I end up with A1n. A1n. This is third column. This is the last column. How many columns are there? N number of columns. This is nth column. A11, A12, A13, second suffix indicates column position. So it is present in third column. A14, A15, etc. A1n. Now let me write the second row elements. A21, A22, A23. Element of the matrix present in second row, third column. Like this, if we continue, A24, A25, look at the first suffix, they are all 2 because we are writing elements row wise, in particular second row elements. The last element in that row is A2n, element of the matrix present in second row, nth column, because it contains n number of columns. Like this. What would be the last row elements? Which is the last row here? Mth row. This is first row, this is second row, third row, like this, mth row, because order of the matrix is m by n, mth row elements now. It is AM1, AM2, AM3. What about last element? AMN. Element of the matrix present in mth row, nth column, AMN. In between, let me write ith row elements. Like first row, second row, third row, it is ith row elements now. All those elements in that row will have first suffix as I. So I write AI1, AI2, AI3, etc. Last element is AIN. These are all ith row elements. Now let me write, say, jth column elements. Observe here, if you consider elements in the first column, all their second suffix will be equal to 1. If I am writing second column elements, their second suffix will be 2. Now I am writing jth column elements. What about second suffix of all these elements? Definitely j. The first suffix will be varying. Look at here, 1, 2, 3, like this it is varying. 1 to m it is varying. What would be the element here? It is present in first row, jth column, means it is A1j. And what about in the second row? This position will have the element present in second row, means first suffix is 2, and jth column, therefore its second suffix is j. What about here? It is the ith row, so therefore its first suffix is I, second suffix is j. Aij denote element of the matrix present in ith row and jth column. And what about here in the last row? This element will be A, M, J, present in mth row and jth column. I hope you followed. Now, this entire matrix is symbolically, in brief, can be written like this. Matrix A equal to matrix whose entries are Aij of order m by n, where I takes the value from 1, 2, 3 up to m, and j takes the values 1 to n. So this is how we write, or we can write I is varying from 1 to m, j lies in the interval 1 and n. This is the brief way of writing the m by n matrix. I hope you are clear with this. What is matrix? What is order of the matrix? And how we can locate each element uniquely with respect to its position. Now let us take a situation where they are given order of the matrix. When order of the matrix is given, is there any method by which I can find out the number of elements present in that matrix? I said, now they are not given the matrix. What are the entries of the matrix? They are not given. Simply they are saying A is a matrix of order m by n. What would be the number of elements present in that? Suppose if they are given the matrix like this, definitely it is possible to find how many number of elements are there. How we can do it? Just by counting 1, 2, 3, 4, 5, 6. So this matrix A is having 6 number of elements. When this matrix is given, count number of elements here, it is found to be 8. The earlier example, it contains 4. So by counting we can tell, but now they are not given the matrix. Instead they are saying only order of the matrix, like A is a matrix of order 2 by 3. Then how many number of elements are there in that matrix? We said already 6. Observe the order 2 cross 3. When matrix of order 2 by 3, we say the number of elements are 6. What is the order of this matrix? 4 by 2. How many elements are there? 8 elements are there. In the earlier example, that is matrix C, it was 2 by 2 matrix. How many elements are there? 4 elements. Able to get any idea now? Yes, I hope you get it. Just by multiplying the number of rows and number of columns in that matrix, you are able to generate how many number of elements will be there in that matrix. As it is a 2 by 3 matrix, 2 into 3 will give us a 6. So many elements that matrix will have. That is obvious. This is 4 by 2 matrix. Multiply those two numbers, 4 into 2, 8. So 8 number of elements are there. So in this way the logic is, if the order of matrix is m by n, then the number of elements in that matrix will be equal to m into n. Okay. Now let me take the other way. The other way means, now they are given the number of elements in the matrix. They are not written the format of the matrix. Simply they are saying the matrix A has 6 number of elements. Then what is the order of the matrix? This is exactly reverse of the previous one. Yes, they are given number of elements are 6. What is the order of the matrix? Can we say that it is equal to 2 by 3? Can you say specifically a matrix which is having 6 elements, definitely it will be of order 2 by 3? Yes? Okay. Now let me write a matrix here. This is also a matrix. What is the order of the matrix? How many rows are there? Row number 1, 2, 3, row number 6. How many columns are there? Only one column. Therefore, what is the order of matrix? 6 by 1. Observe how many elements are there in that matrix? 6 elements. For us also they are given 6 elements. Asking what is the number of, what is the order of the matrix? So here order of the matrix is 2 by 3. Here it is 6 by 1. Let me write some more. Again I written 6 elements. Number of elements are 6. What is the order of this matrix? How many rows are there? Only one row. How many columns? 1, 2, 3, 6. So therefore, order of this matrix is 1 by 6. So here the idea is, when we know the number of elements in the matrix, we cannot tell specifically the order of the matrix is going to be so and so. Instead, we can say the possible orders of the matrix. Whenever they are given order of the matrix, number of elements are 6. The possible orders are what? One is 2 by 3, another is 6 by 1, another is 1 by 6. Can I guess one more? It is 3 by 2. 3 by 2 matrix will also have 6 number of elements. So in this way, we can say possible orders of the matrix which contains 6 number of elements. I hope you followed this. Now assume that they are given some matrix contains 8 number of elements, like here. 8 number of elements are there. What would be the order of matrix? Can I say specifically it is only 4 by 2? No. Then what is the procedure to find the possible matrices where all those matrices contains 8 number of elements? You need to find simply ordered pair of numbers, ordered pair of natural numbers, such that their product gives us the total number of elements in the matrix. The number of elements in the matrix, 8. Now let me write 1, 8. 1 into 8 will give us 8. Another pair of numbers, 8, 1. 8 into 1 is 8. Let me write another pair, 2 into 4. 4 into 2. So here I listed the set of ordered pair of natural numbers such that their product is equal to 8. They itself are the possible order of the matrix. One is 1 cross 8, that is 1 by 8 matrix, only one row 8 columns. This is 8 by 1 matrix, 8 rows 1 column, still it contains only 8 elements. 2 by 4 matrix, 2 rows 4 columns, it contains 8 elements, 4 rows and 2 columns. So this is the procedure of finding the order, possible order of the matrix when the number of elements in the matrix are given. Now let me move on to discussing example where it is required to construct a matrix. When they are given order of the matrix, they are not given elements of the matrix. Instead, a formula or a rule to find elements of those matrix. For example, construct 2 by 3 matrix whose elements are given by Aij equal to half of I minus j. What they did here? Required to construct a 2 by 3 matrix. A matrix containing 2 rows and 3 columns, whose elements are described by this. Element of the matrix present in ith row, jth column is half of I minus j they are given. The procedure to construct matrix is, first we will write a general 2 by 3 matrix. You know already how to write it. Here it is. I written already. It is a 2 by 3 matrix. Now let me find out the values of these elements one by one. I want to know what is A11. How to find A11? Use this rule. It is half of I minus j. What is I? 1. What is j? 1. That is equal to 0. I want to know what is the value of A12. A12 is half of 1 minus 2. Because I value is 1, j value is 2. How much you are going to get? Minus 1 by 2. Then A13 value. It is half of 1 minus 3. If you simplify, you are going to get minus 1. Now find the values of second row elements. A21 is half of 2 minus 1, because I is 2, j is 1, that is equal to 1 by 2. A to 2 is half of 2 minus 2, that is 0. A to 3, half of 2 minus 3. If you simplify, you are going to get minus 1 by 2. Now let me replace these values in their respective position. First row elements a11, a12, a13. 0, minus 1 by 2, minus 1. Second row elements a21, a22, a23. Here they are. 1 by 2, 0, minus 1 by 2. So this is what the required matrix they are asking. What we done? We constructed a 2 by 3 matrix whose elements are described by Aij equal to half of I minus j. I hope you followed this. With this, now we will move on to discussing what are the different types of matrices. Types of matrices. First one, row matrix. The name itself indicates a row matrix means a matrix which has only one row is called as row matrix. Similarly, column matrix refers to a matrix which is having only one column. Now let me write some examples for this. Row matrix. Say matrix A equal to, say I write the elements as 1 by 2, 0, root 5. Only one row it contains. What is the order of this matrix? 1 by 3. So this is an example of row matrix. Whatever may be the number of columns, irrespective of number of columns, if you just observe the number of rows is only one, so we can say that it is a row matrix. In general, I can write matrix A is a matrix whose entries are Aij of order 1 by n. I value is fixed, it is not varying, it is equal to 1, whereas j is varying from 1 to n. Because look at here, this is a11, a12, a13. a11 means n number of columns are there. The elements will keep continuing a14, a15, a16, how many number of columns it contains depending on order. So this is general way of writing the row matrix. Column matrix. If I write matrix B equal to, look at how many columns are there. Number of columns only one. The number of rows 1, 2, 3, 4. Therefore, order of matrix is 4 by 1. As this matrix contains only one column, it is called as column matrix. So now I can write matrix B is a matrix whose entries are Bij, where I is varying from 1 to m and j takes only one value, namely 1. So it is a matrix of order m by 1. Here in particular 4 by 1 because it contains 4 rows. If it contains m number of rows, the column matrix will become m by 1. Now let us see what is a square matrix. Again, the name itself indicates square matrix. The shape of the matrix is square in shape. When it will look like a square. If you observe this, they are not squares, they are rectangular matrices we see. Now square matrix means if the number of rows equal to number of columns, we say such matrix is a square matrix. Let me write an example. Say matrix C. Say it is 1, 2, 3, 4. Matrix D. So it is 9, 8, 7, 6, 5, 4, 3, 2, 1. So what is the order of matrix? 2 by 2. Here order of matrix is 3 by 3. So it is a square matrix of order 2 by 2, square matrix of order 3 by 3. You can modify this. Instead of saying square matrix of order 2 by 2, you can say simply square matrix of order 2. That is more than enough. Because as the square matrix itself indicate, number of rows equal to number of columns, enough to say any one number. Square matrix of order 2 is enough. It is equivalent to saying matrix of order 2 by 2. Similarly, this matrix can be said as square matrix of order 3. So, any matrix of order m cross n is said to be square matrix if and only if m equal to n. When the number of rows is equal to number of columns, then only we say that that matrix is a square matrix. Now let us say the elements of this square matrix. We can classify them as diagonal and non-diagonal elements. Remember the classification of elements like diagonal and non-diagonal elements can be done only in square matrix and not in any other rectangular matrix. Now let us see how to classify the elements of square matrix, some as diagonal, some as non-diagonal. As you know, square will have two diagonals. This is a diagonal one. This is called the principal diagonal, and the other one is a secondary diagonal. In the matrix chapter, when we say diagonal means, it always refers to principal diagonal. Remember that. Now, the elements of square matrix lying along the principal diagonal are treated as diagonal elements. Now, let us take this matrix. Draw principal diagonal. Which elements are lying along this line? 1 and 4. So, 1 and 4 elements of this matrix are called as diagonal elements of the matrix C. What about 3 and 2? They are called non-diagonal elements. Whereas in the case of matrix D, it is a 3 by 3 matrix. Now draw principal diagonal. Observe the elements lying along this principal diagonal, namely 9, 5, 1. So 9, 5, 1 are treated as diagonal elements of the matrix D. Obviously, the rest of the elements are called as non-diagonal elements. Be clear with this, diagonal and non-diagonal elements. Now, suppose if I write one more matrix, say matrix E equal to, only one entry I written. Is this a matrix? Yes, definitely. Then how many number of rows, how many number of columns are there? Only one row, only one column. So order of this matrix is 1 by 1. Can we say that it is a square matrix? Yes, definitely. According to the definition, number of rows equal to number of columns. Yes, they are equal. So therefore it is also a square matrix of order 1 we say. This is square matrix of order 2. This is square matrix of order 3. What are diagonal elements in this matrix? 7. What are non-diagonal elements? No non-diagonal elements. I hope you followed this. With this now, we will write definition of a diagonal matrix. Before that, let me write a square matrix with respect to their positions, elements. I write A11, A12, A13, A21, A22, A23, A31, A32, A33. Why I written this means, by looking at the suffixes we can say which elements are diagonal, which elements are non-diagonal. Observe the diagonal elements and observe their suffixes. They are equal. So I write Aij is a diagonal element. Aij in a square matrix is a diagonal element when I equal to j. When their suffixes are same, it represent one of the diagonal element. Maybe I equal to j. Maybe I and j both are 1, a1 1. When both I and j becomes 2, a2 2, it is also diagonal element. When I equal to j, each of them equal to 3, it represents a3 3. It is also diagonal element. Now Aij is non-diagonal element when I different from j. Look at this element. Suffixes 1 and 2 are there. They are different. When they are different, it is going to represent non-diagonal element. A12, A13. Look at all the non-diagonal elements. They are having different suffixes. So you have to remember this. Aij element will become diagonal element whenever I equal to j. Aij is a non-diagonal element whenever I different from j. Okay. What this diagonal matrix is? Diagonal matrix is basically square matrix in which non-diagonal elements are all 0. Write an example for this. Say matrix A equal to, I write 7, 0, 0, 0, 8, 0, 0, 0, minus root 2. I said diagonal matrix is a square matrix in which all non-diagonal elements are zeros. Check, is it happening here or not? Observe the non-diagonal elements. They are all 0. It is a square matrix. So therefore, it is an example of diagonal matrix. You can write a diagonal matrix of order 2. I write 2 0 0 1. It is also square matrix whose non-diagonal elements are 0. Therefore, it is an example of diagonal matrix of order 2. Diagonal matrix of order 3. Now let me write a matrix A whose entries are Aij, which is a square matrix of order m by m, square matrix of order m, is said to be diagonal matrix if Aij must be equal to 0. Yes, what elements of the square matrix must be 0? Non-diagonal elements. So how to represent non-diagonal elements? When their suffixes are different. Aij value is 0 when it is a non-diagonal element, and Aij equal to non-zero elements. Aij equal to 0 when I not equal to j. Symbolically we can write like this. This is the definition of diagonal matrix in terms of symbol. Now let me take a definition of scalar matrix. Scalar matrix is a diagonal matrix in which each diagonal elements must be equal. That is, say I write B equal to, I write 7 0 0 0 8 0 0 0 minus root 2. Yes, of course it is a diagonal matrix. Now check whether each diagonal element values are one and the same. No, they are different. A11 is 7, A22 is 8, A33 is minus root 2. It should not be the case. They said it is a diagonal matrix in which all the diagonal elements values are same. So now I will change these diagonal elements to 7. Now clearly it is an example of scalar matrix of order 3. Let me write one more. Say matrix C equal to, I write half, 0, 0, half. Clearly it is an example of scalar matrix because it is a diagonal matrix and each of the diagonal element are same. That number is 1 by 2. Therefore it is a scalar matrix. In general, in symbols, how we can write? Matrix whose entries are Aij. Say matrix A whose entries elements are Aij. It is a square matrix and elements of the square matrix is given by Aij equal to 0 when I is different from J. That is non-diagonal elements must be equal to 0. When I equal to J, this element refers to what? Diagonal element. What must be the value of diagonal element? All the diagonal elements must be same. We don't know, that number can be 1 by 2, that number can be 7 or it can be any real number. So let me represent it by k, where k is some real number. So this is the way of writing the scalar matrix in terms of this precise notation. Let me write identity matrix. A matrix is said to be identity or unit matrix also it is called. A matrix which is a scalar, it is basically scalar matrix in which each diagonal element must be equal to unity. In scalar matrix we said each diagonal elements can be any real number. In particular, if that real number is equal to 1, then such a scalar matrix is called as identity matrix. Now let me write the example for that. So this is scalar matrix because the non-diagonal elements are 0, diagonal elements are all same. So it is a scalar matrix. In particular, that real number is 1. So therefore it is a unit matrix or identity matrix of order 2. Now let me write identity matrix of order 3. It is 1 0 0 0 1 0 0 0 1. That is identity matrix of order 3. Usually these identity matrices are denoted by the capital letter I. Whenever we write I in this chapter, capital I, it always stands for identity matrix. Now let me write the definition of identity matrix in brief notation. So I equal to a matrix whose entries are Aij. Say order of the matrix is m by m, means square matrix of order m by m. Now elements of the matrix Aij, either it is 0 or 1. Observe here. Elements of the matrix either 0 or 1. When it will be 0? When it is non-diagonal. When it will be non-diagonal? When their suffixes are different. Now when it will be 1? When it is diagonal element. How to represent diagonal element? Their suffixes are same. When I equal to G. So very important this. You need to practice to write this. Just remember how a diagonal element is represented. Aij. When I equal to j, that element represent diagonal element. When I is different from j, that is suffixes are different, it is no more a diagonal element. If you remember this, you will be able to represent all these matrices. Next one, zero matrix. Simple definition, name itself indicate a matrix in which all the elements are zero, all the entries are zero. Such a matrix is called as a zero matrix. As an example, I can write whatever may be the order you write. You write all the entries as zero. So it is a zero matrix, or it is also called as null matrix, because all the entries are zero. Null matrix of order 2 by 3. It is a null matrix of order 2 by 2. Like here, identity matrix is denoted by capital I. Null matrix is generally represented by capital O. Whenever we write capital O, it indicates it is a null matrix. That is, each and every entry of that matrix is zeros. I hope types of matrices are clear. They are very simple. Row matrix, a matrix which is having only one row is called row matrix. Column matrix, a matrix having only one column is column matrix. Square matrix, a matrix of order m by n is said to be square matrix if m equal to n, that is number of rows equal to number of columns. Diagonal matrix is a square matrix in which all non-diagonal elements are zero. Scalar matrix is a diagonal matrix in which each diagonal element's values are same. Identity matrix, it is a scalar matrix in which each diagonal element's value must be equal to 1. Finally, zero matrix, a matrix whose each entry is zero irrespective of order is called as null matrix. Remember, identity matrix is always denoted by capital I. Null matrix is denoted by capital O in this chapter. With this now, we will move on to discussing when to say that two matrices are equal. Very important one. Now we will discuss that. Okay. To discuss equality of matrices, here I considered some set of matrices. 4 matrices I took. To say that two matrices are equal, now I take A and B matrices. To say that two matrices are equal, don't observe in the beginning only the elements. As the matrix A contains elements 1, 2, 3, 4, B also contains the same elements 1, 2, 3, 4, therefore they are equal. No, this is not the way how we decide two matrices are equal. First condition is we have to check their order. That is, order of matrix A is same as order of matrix B or not. If they are different, no question of checking whether they are equal or not. Straight away you reject it. They cannot be equal. So here I write A is different from B. A not equal to B. So first condition is order must be same. Now let me take A and C. What is the order of matrix A? Square matrix of order 2. Order of matrix C, same square matrix of order 2. Orders are same. By having the same order, we cannot say straight away they are equal matrices. I cannot say straight away A equal to C. Next part is I have to observe the elements. Of course, both contains the same elements 1, 2, 3, 4. Again, in this case, we say that these two are not equal, even though they contains same elements. The second condition says the corresponding elements must be same. What is meant by corresponding element? They are saying with respect to position of the elements. Now let me write here. A11, element of the matrix A, present in first row, first column. In matrix C, which element is corresponding to this means an element of matrix C present in the same position, first row, first column. These two must be equal. Now what is A11? It is 1. What is C11, it is 3. They are different. Is it clear? So like this, we need to check all the corresponding elements, not any one. So I have to check, is A11 equal to C11? Suppose this element is also 1. If this is 1, this is 1, don't conclude that matrix A is same as C. You check with other element also. Is this the second element is same as this? That is A12 is equal to C12 or not. If it is equal, then continue. A21 is equal to C21 or not. A22 is equal to C22 or not. In case if all these conditions are satisfied, all the corresponding elements of both the matrix are equal, then only we say that two matrices are equal. So instead of this matrix containing 1, 2 in the second row, if it contains in the first row 3, 4 in the second row, then we might have said matrix A is same as matrix C. Say for example, if I write D matrix as 1, 2, 3, 4, then I can say these two matrices are one and the same. I can write A equal to D. This is what equality of matrix. First thing, order must be same. Second thing, their corresponding elements are all equal. Then only we say that two matrices are equal. With this definition now, if they are given matrix A is equal to matrix D, if matrix A is same as matrix D, then find X and Y. They are not asking us to check whether A and D are same or not. They are given A is same as D, but D matrix contains some unknowns. What would be the values of X and Y they are asking? Now A equal to D, matrix A contains 1, 2, 3, 4 elements. Matrix D contains elements 1, X, Y, 4. Now since they are given equal, I can equate the corresponding elements. So on equating, corresponding elements, we get 2 equal to X. The element corresponding to 2 in the second matrix is X, 2 equal to X. And not only this, the element 3 must be equal to Y. Therefore, we get X equal to 2 and Y equal to 3. So on equating corresponding elements, we are able to get the values of unknown. So this is all about a little basic about matrix. We came to know what is meant by matrix, what is order of the matrix. When order of the matrix is given, it is possible to tell how many number of elements are there. When they are given how many number of elements are there in the matrix, it is possible to decide the possible order of the matrices in which they contain same number of elements. Next we discussed the types of matrices and finally equality of matrices. With this idea, you should be able to complete the examples given in exercise 3.1. So please try it and you will be successful, no doubt in that. Otherwise, anyhow, in the next video, I am going to cover all those examples. We shall meet you in the next video class. Thank you.